Hello everyone, in this video we will learn about DDA line drawing algorithm. First of all, let's see what is DDA. DDA stands for Digital Differential Analyzer. All we know that computer screen consists of many pixels. As you see here, computer screen looks like this. In order to draw a line on computer screen, we should consider pixel and its computations. DDA is the algorithm that makes computer find that which pixels to plot and which computations are required to calculate appropriate pixels. We can show each pixel of computer screen as x and y. We're given initial points x1, y1 and ending points x2, y2. All we need is to find out intermediate pixels between initial point and ending point. Here DDA algorithm helps computer decide which pixel to choose. This is general line equation. Y equal mx plus c. Here m is slope, c is intercept point in y-axis. x1, y1 is starting point of line, x2, y2 is ending point of line. The formula of slope equals to y2 minus y1 divided by x2 minus x1. If the current point of the line is xk, yk, and the next coordinate is xk plus 1, yk plus 1, then the slope between these 2 points will be yk plus 1 minus yk divided by xk plus 1 minus xk. This is how we find all the intermediate points from starting point to ending point. We will start to implement an algorithm from the initial point, and we will find all next coordinates, and we'll continue the same process until we reach to the end points. Algorithm will finish wherever we will get the end points x2, y2. Now our first step is to get endpoints of the line and to calculate the value of slope. We can have one of these 3 possible values of slope that will determine which case to choose. If m is less than 1, then we will continue our calculation according to case 1. What is case 1? If slope is less than 1, it means that changes in the value of x are more than changes in the value of y. So x coordinate will change with unit interval. It means that the next coordinate of x will increase by 1 or decrease by 1. When coordinates will increase and when will decrease. It depends on the types of lines. You will easily understand it in the next slide, so don't worry if it confused you. Now you can just look at this side. Okay? So as we said, x coordinate will change with unit intervals. So xk plus 1, the next coordinate of x will be xk plus 1. So next coordinate of x will increase by 1. If you remember our formula of slope, here we saw in the previous slide, m equal yk plus 1 minus yk divided by xk plus 1 minus xk. Here if we put the value of xk plus 1 here, we will get 1 here, so we can easily find the next coordinate of y from this equation. So the next coordinate of y will be yk plus m. It means that the next coordinate of y will increase by m. As a result, if slope is less than 1, our next coordinate will be xk plus 1, yk plus m, or xk minus 1, yk minus m. I will explain this in the next slide, so don't confuse yourself. Now let's turn into second case, when slope is more than 1. If slope is more than 1, it means changes in the value of y are more than changes in the value of x. So y will change with unit interval. The next coordinate of y will be the current coordinate of y plus 1. Again, we will put this value in our formula instead of yk plus 1, and we will get 1 here. So our equation will be xk plus 1 minus xk equal 1 divided by m. So here xk plus 1 is our next coordinate. Next coordinate of x will be current coordinate of x plus 1 divided by m. In the second case, when slope is more than 1, next coordinate will be xk plus 1 divided by m, yk plus 1. Now let's see third case, when slope is equal. Okay, in the third case, when slope is equal 1, x and y will change equally. So next coordinate of x and y will increase by 1 or decrease by 1. Now let's see classification of lines. We can have two types of line. Line starting from left and ending at right, and line starting from right and ending at left. In the first case, the values of x and y will increase. It means that depending on the values of slope, we will take these values for our next coordinate. When line starts from right and ending at left, it means that the values of x and y are going to decrease. So in this situation, we will take second values according to the value of slope, of course. If we summarize, we can have four cases. Line starting from left and ending at right when slope is less than 1. Next coordinate will be xk plus 1, yk plus m. Line starting from left and ending at right when slope is more than 1, then the next coordinate will be xk plus 1 divided by m, yk plus 1. Line starting from right and ending at left when slope is less than 1, then next coordinate will be xk minus 1 and yk minus m. And the last case, when line starting from right and ending at left when slope is more than 1, the next coordinate will be xk minus 1 divided by m and yk minus 1. I hope you understood it fully. Now let's see all steps in DDA algorithm, so it will be easy to understand it fully. First of all, we need to get the endpoints in order to calculate the slope. After calculating the value of slope, we need to identify the line type. We can have one of these four situations. So we will identify the line type and the value of slope, so we will choose one of these four formulas. After identifying the line type, we will implement the appropriate formula according to the line type and the value of slope. And we will repeat the process until reaching the endpoint. Now let's see example for DDA algorithm. Draw a line between 2, 1 and 6, 9 using DDA algorithm. First of all, we need to find the value of slope. We know the formula and we put these values in the formula and find the value of slope, which is 2 and more than 1. Now we need to identify the type of line. As you see here, 2, 1 point is in the left side of 6, 9 point. It means that line starting from left and ending at right. So we will choose this case, line starting from left and ending at right when slope is more than 1. So our next coordinate will be xk plus 1 divided by m, yk plus 1. We will use 1 divided by m all the time. We will add to xk. That's why it will be easy to calculate it from the beginning, then add it at every iteration. So 1 divided by m equals 0.5. We calculated it. Now we can start our calculation. In the first time, we need to write initial points to 1, and we will plot as they are. So our first point of the line is 2, 1, as it is given here. Now let's calculate the next coordinate of x, which will equal to the current coordinate of x plus 0.5. 2 plus 0.5 equal 2.5. So we write it here, and then we calculate the next coordinate of y, which will increase with unit intervals, so it will be 2. Now here, when we plot the value of x, we cannot write it like this. We need to round it. So we will make a rounding operation, and it will be 3 here. And we will plot the value of y as it is. So our coordinate became 3, 2. Now we will continue the same process, and we will repeat until reaching the end point. So next coordinate of x will be 3, and next coordinate of y will be 3. So we don't need any rounding function here, so we can plot as it is. So our coordinate became 3, 3. Now we will repeat the process, 3.5, 4, and we will round it again, and we will plot as 4. Then the next value of x will be 4, and the next value of y will be 5. So the next coordinate will be 4, 5. Then we will repeat the process, 4.5, 6. So we will round it here. It will be 5, 6, and the next coordinate will be 5, 6. Then again we will continue the process, 4.5 plus 0.5 equal 5, and the next coordinate of y will increase by 1 again, and it will be 7. So 5, 7, and we will plot them as they are. We don't need any rounding function. Then xk plus 1 equal 5.5, and yk plus 1 equal 8. In the plotting, we will again round it, and the next coordinate will be 6 and 8. The last operation, 5.5 plus 0.5 equals 6, and yk plus 1 equal 8 plus 1 equals 9. So as you see here, we reach the end point. It means that we finished the algorithm. We need to stop here. We found all the intermediate points between initial and ending points. So the points of the lines are 2, 1, 3, 2, 3, 3, 4, 4, 4, 5, 5, 6, 5, 7, 6, 8, and 6, 9. The main disadvantages of DDA algorithm is, as you saw in the example, we used rounding and floating computations, which are very expensive operations for computer. That's it. Thank you so much for watching this video. I hope it was helpful. Good luck in your exam. Bye bye.